What's up? So this is my video walkthrough for Lab 4 of Mechatronics. So this lab actually involved a little less coding than normal. First, we have the motor pwm.c file, where we are writing the functions, to set the correct registers and pins for our PWM features. We're keeping track of whether or not the PWM is enabled, and we are just setting everything up. We're setting some sort of limit to the PWM so we don't accidentally blow up the motors horribly. Then here, to actually enable it, then it's just a bunch of binary logic to switch the right registers from 0 to 1. We keep track, obviously, if it's enabled or not. Simple functions to return if it is. And then actually setting them when we take in some sort of PWM. This logic is symmetrical for the left and right with their respective ports and registers. We just set those to the right values and also just some simple functions to return them. Then, let's see, we also put it all lab for tasks from scratch. And I think also .h, but from the .c, you get the .h. So the way that I chose to implement it was I have these global PWM left and right and a duration variable. So these are just to keep track of what the PWM value should be at a certain point from a certain command. And then we have the set PWM function that will actually allow us to set those, set all three of those global variables based on whatever that takes in. And the reason I did that was so then in message handling we could call this function without any association to any task, because then it was just the easiest way I thought of to end the task after a certain interval. So we just keep track of this interval, and then in message handling over here, we call the function for, I'll go back in a little bit, but for that like message type, we call set WPM, and we pass all those values into the function, so we can keep track of that structure that we've had going of activate the task, and then actually set the task to run at a certain time. Then let's see, just a simple function to stop the PWM, just because I noticed I was calling that a lot. And then I have this chat power function that's actually doing the actual chatting to see if the voltage is really low, first of all. Then we say that the power's off, we haven't even turned the car on because it's that low. The batteries probably aren't there. And then just a check to make sure that we're not below some sort of safe threshold so that we're not, straining our batteries. And these tasks also just double check, stop the PWM, just make sure that's not running at all. Then we have send PWM, which I think is just for the lowercase p command. This just checks checks the power, make sure we have enough voltage, and then just enables the PWM with those global values that were set earlier. I initially had messages coming out of this, but I realized later in the lab we don't actually need any messages there. And then for the send PWM time, that's going to be a similar idea, except I decided to keep track of the start time when this task was first initiated. Probably could have taken better use of the time since last used variable that's passed in, but I couldn't think of how. So, if the start time is already is zero, then we set that current time as the start time, so that means it's the first time the function's been called. If we can't check the power for whatever reason, we just reset everything. If we're below any sort of power thresholds, then we go ahead and just enable everything. We turn on the motors with the correct PWM, and then here's that leftover when I was sending messages of the values until I realized we didn't need that. And then just a quick check to see if the time now, if the elapsed time since the function started, if that's past the duration of the PWM, then we just go ahead and stop it. We stop the PWM, the start time PWM is set to 0, the end of the duration of it, and we actually go ahead and cancel the task. So I think when the uppercase P command is set, basically we have the task firing off every second, and it's just keeping track of what the current time is and checking if the time has passed. And once the time has passed, we need to cancel the task, so we no longer need it to check. Then here's just a quick task definition for actually sending the system ID data. So that's going to be that Q command that sends the time, both PWMs and both encoder values. We first just have to call set encoder to make sure that our encoder values are accurately set to whatever they currently are. I have a global function that's called to actually set those encoders, and then this just saves the current value to this global variable encoder left that's just passed on from a shared file that I made somewhere to keep track of all the shared information. And then in message handling, for this lab, we have our lowercase p command, pretty standard. Like I mentioned, I did just to pass that PWM information, I just made a function that I could pass it in, since it already has all of the different lab tasks within scope by default, message handling. So I just made a function to pass it in, and then I activate the task to run one time. P is very similar, except I'm passing in an actual interval there, and I'm just setting the task to run constantly. Basically, you want to run every few milliseconds just to double check if the elapsed time is hit and if we need to turn off the PWM. Then we have a pretty basic stop command, just basically if this task runs. Oh, this calls the stop PWM function from earlier. I think that's also reused at certain points, but I also made that into a task so we could stop PWM at any point with the S command. And the uppercase S behavior was just straight up incorrect in the documentation. I think I made it just loop because I thought that was funny, but it has no practical use. Then case Q and uppercase Q, those are just calling that task send system ID either once or at some interval so that it loops. Then finally we have the lab for motor main, which is very similar to just all of our previous mains, basically copy and pasting. All we're introducing here is we have the send PWM, the stop PWM, the send system ID data, and the send PWM time task. That I went over how those are defined. We initialize those 4 tasks, and we have run those tasks if they are ready at any point inside of our main loop. I think that's why I have to initialize the motor PWM, make sure that actually it's just the MATLAB code I use to take the left and right encoder data as well as the PWM values and basically convert them into some sort of velocity transfer function that we could use if we run that, which maybe was a bad idea because it will take a while. But as you can see, it's giving us a transfer function based on what I provided it. We know that this is a first degree one pole system. I did have better luck getting the system validation to match up correctly when I introduced to 0, but I'm actually not sure if that's needed. However, it is still there's a lot of noise in the data that's being recorded, so it doesn't line up perfectly with the system, but it's probably good enough for the what we're going to be using it for. And now I will go ahead and cut to some footage of the robot running. Okay, so now I'm just going to show off some of the functionality of the robot for this lab. So here we just have the Q message, which is sending the current time since the robot's been running. We have the 2 PWM values, which are currently set to 0, and we have the encoder data for both of the motors. Then if I go ahead and click send CSV command and load up some commands I wrote earlier, and let's have those just run at like 500 milliseconds. Yeah, that's probably good. And now pan over to the robot. And it moves. Oh, it's running. Wow, isn't that so cool? Wow. Isn't that crazy? And if you go back up here to those Q, you can see the PWM values changing as they're being updated in the robot. Cut over here. If I go ahead and turn the car off, so I cut off the voltage, cut back to that, you can see first the plot, there's a steep drop as it slowly, the filter's trying to converge to 0. And then if you go to the serial monitor, let's see, let me make clear this command so you can see it a little better. But as you can see, every second right now we're getting this battery low warning, kind of telling us that our voltage is dropped beyond under the 4 volt threshold. And I think that was everything.